Welcome, students. In the last class, we learned how to complete the square. Today, we're going to use that as a tool to help us solve quadratic equations. We're going to look at one example first, and then once we've done that, we're going to write out the steps one at a time. So you've got a written copy of those, and then we're going to go through a couple more examples. So let's just jump into the first example. Let's solve x squared minus 4x equals -2. This is not an equation that could be solved by factoring. If you tried to move this 2 to the other side by adding 2 to both sides, you would end up with a polynomial that's not factorable. So that method doesn't work, and we really need this completing the square method. So what I'm going to do is I'm going to rewrite the equation, but I'm going to leave a little bit more space on the left-hand side. And you'll see why in just a moment. Now, on the left-hand side, we have x squared minus 4x, and we just learned that we can complete the square. So I want to do that. What can we add to complete that square? Well, we've got the coefficient -4. If you divide that by 2, you get -2, and then when you square it, you get +4. So we can add 4 to complete the square here. However, we are looking at the context of an equation, and so if we add 4 to one side, what else do we have to do? We have to add 4 to the other side. When we use completing the square, in the context of solving an equation, we need to be adding the same quantity to both sides as we're completing the square. Now that we've done this, we can factor the left-hand side, and then we can solve using the square root property. When we factor the left-hand side, we end up with x minus 2 squared, because -2 is what you get when you divide -4 by 2. And then on the right, -2 plus 4 is 2. And now we have something that looks like it's in a form that we've solved before. We can use the square root property here. The square root of the left-hand side is x minus 2. On the right, when we take the square root, we get plus or minus the square root of 2. And then to get x alone, we add 2 to both sides, giving us x equals 2 plus or minus the square root of 2. All right, the only thing that's really new here is while we're completing the square, we have to add the same quantity to both sides. But everything else is something that we've already done. We've already completed the square. We did that last lesson. And we have solved equations in the form something squared equals a number with the square root property already last week. So this is just combining a couple of things that we've already seen in a larger context. I do want to write out step by step how we solve these quadratic equations by completing the square so that you've got something that you can follow while you're doing the practice problems. So let's write out these steps. The first thing we're always going to want to do is get all the variable terms on one side and the constant term on the other side. Now this was done for us already in this problem. We had the variable terms on the left and the constant term on the right. If you start off with all the terms on the same side or any other configuration, you need to start by getting the variable terms alone on one side and the constant term on the other. Once you do that, you're in the right format to complete the square, and you can do that by adding the same quantity to both sides. Once you complete the square, you need to factor this perfect square trinomial so that it's in the form something squared equals a number. And then you can solve using the square root property, taking the square root of both sides, remembering that plus or minus symbol, and then getting x alone. Let's do a couple more examples together. Let's solve y squared plus 3y minus 5 equals 0. Now here we do have to do the first step. we need to get all the variable terms on one side and the constant term on the other. To do that, we can add 5 to both sides, and that pushes the constant term to the other side. Once we've done that, we can move on to the next step, which asks us to complete the square by adding the same quantity to both sides. So we need to take this coefficient, divide it by 2, and square it. 3 divided by 2 is 3/2, and when we square that, we end up with 9/4. So we need to add 9/4 to both sides of the equation. Next, we can factor this perfect square trinomial on the left. When we factor it, we get y plus 3/2 squared. And then on the right, we have 5 plus 9/4. This is a math problem that we can do. 5 plus 9/4 is the same as 5 over 1 plus 9/4. We need a common denominator, which is going to be 4. 5 over 1 becomes 24ths, and 24ths plus 9/4 is 29/4. So once we've simplified that, we now have something in the form something squared equals a number, and we can use the square root property. When we take the square root of the left-hand side, we get y plus 3/2. On the right-hand side, when we take the square root, we get plus or minus the square root of 29/4. However, we can split that up into the square root of 29 over the square root of 4, and the square root of 4 is just 2, so that right-hand side simplifies into the square root of 29 over 2, plus or minus. So I'm going to write this up here. We've got y plus 3/2 equals plus or minus the square root of 29/2. And to get y alone, we need to subtract this 3/2 from both sides. When we do that, that gives us a negative 3/2, and then plus or minus the square root of 29/2. And this is our answer. It looks thoroughly complicated. This is a very complicated answer. We've got multiple terms, we've got a plus or minus symbol, they both have fractions, we've got a square root in there. It looks scary, but this is the solution. When we have a quadratic equation that we can't solve by factoring, that means that we're going to generally have solutions that are irrational, that have square roots in them, and that's just how it is. Let's take a look at one more problem together. Let's solve. And this time I want to take a look at x squared plus 6x plus 8 equals 0. The first step requires us to get that constant term on the other side. We can do that by subtracting 8 from both sides, leaving us with x squared plus 6x on the left and negative 8 on the right. Then we can complete the square. We do this by taking the coefficient, dividing it by 2, and squaring it. 6 divided by 2 is 3, and when we square that we get 9. So we need to add 9 to both sides. And then we can factor the left-hand side. X squared plus 6x plus 9 factors into x plus 3 squared. And on the right, we can simplify that. Negative 8 plus 9 is just 1. Now that we've factored the perfect square trinomial, we can solve this using the square root property. When we take the square root of the left-hand side, we get x plus 3. And then on the right, we've got plus or minus. The square root of 1 is just 1. So we have x plus 3 equals plus or minus 1. To get x alone, we subtract 3 from both sides. So we get x equals negative 3 plus or minus 1. And this gives us two different solutions, negative 3 plus 1 or negative 3 minus 1. Negative 3 plus 1 is negative 2, and negative 3 minus 1 is negative 4. So we end up with x equals -2 or x equals -4. I do want to point something out. We used completing the square here because that's what we're learning today. However, if you look at the original equation, this could be solved much easier by factoring. If we factor x squared plus 6x plus 8, we get x plus 2 times x plus 4 equals 0. If we set each factor equal to 0, x plus 2 equals 0, or x plus 4 equals 0. And if we isolate x in each of those, we get x equals -2 or x equals -4. So in this case, we got the same answer using a lot less work by factoring. However, when you've got one that can't be factored, you can't get a solution unless you go through a process like this. So today, when you're doing your homework, I want you to get practice with completing the square, because that's what we're studying. But in a future lesson, we're going to think about these problems and decide when is it best to factor, when is it best to use the square root property, when is it best to use completing the square, and also when is it the best to use the quadratic formula, which is what we're going to learn soon.